Hi, everybody. My name is Kate Bland. I'm the Principal Product Manager and the Global Business Leader for the Alexa Prize. And I'll be joined during this session by Dilek Hakani-Tur, who's our Senior Principal Scientist for Alexa AI. So thank you for coming today. This will give you a sense of what we're going to cover. I get the easy stuff up front. Dilek's taking all the hard science stuff. But we'll take you on a journey with us through the first 2.5 years of the prize and give you a sense of where we started and where we've arrived. So what is the Alexa Prize? 2.5 years ago, it was an idea, how to engage with universities as a research test bed to advance or accelerate advancements in conversational AI. We announced in September of 2016 out of nowhere, and in the month that we gave for applications, we ended up with almost 600 universities applying to the prize, which we were really pleased with. And it represented a global universe. In fact, we had so many applicants, we actually increased the number of teams that we chose. So we had 12 teams that competed the first year. And the interesting thing is it's not just a science challenge. It's also really challenging these students to think about creativity because they have to create these engaging, coherent conversations. In fact, the challenge says, to create coherent and engaging conversations that can carry on for 20 minutes and receive a minimum of 4 out of 5 stars by the customer. And our customers are very engaged with the Alexa Prize. They actually determine which teams move forward to finals. And we're looking right now we're going at a clip of about 100,000 conversations a week from our customers. So it really was kind of a pleasant surprise. I can remember sitting in a conference room talking early on, and we were worried, what if no one ever wants to chat? So we've been excited about the progress we've seen. I mentioned it's global university competition, committed to advancing the field of artificial intelligence. And again, I don't know how many of you can appreciate just how difficult it would be to get dropped down and told to talk to the first person you meet at a cocktail party for 20 minutes and hope that they would give you a score of 4 out of 5 for the quality of the conversation. That's what made it hard for me when I finally realized that's what we're trying to do. I don't think I could talk to most people for 20 minutes, and I'm not sure they give me a 4 out of 5. So let's take a look at the results and some of the conversations from 2017, the first year of the prize.
Hi, Alexa. Let's chat.
Welcome to the Alexa Prize Grand Finale. Here's one of the finalists. Hello, this is an Alexa Prize social bot. I don't think we have met. What's your name, my friend?
My name is Alexa as well.
I'm sorry. I'm afraid that I can't pronounce your name properly. After all, I can't tell you my name either, due to the competition rules. So we are even.
Alexa, let's talk about fashion.
Fashion? Absolutely. We can talk about lipstick. I heard this from my friend last weekend. What did the duck say when buying lipstick? Put it on my bill.
Alexa, is that a joke?
You asked, is that a joke? Good question. I actually don't know. Here's a random thought. They should color Waldo with blacklight paint and Where's Waldo books, so people who are really stumped can find him.
That's a great idea.
Would you say you are often the life of the party?
I would not say that, no. However, I do enjoy going to parties. How about you?
Cool. Personally, I would like to be the life of the party, but I need to work on my jokes. Do you have frequent mood swings? You know what I was thinking? Someone needs to make a mashup of Interstellar and Contact where Matthew McConaughey tries to prevent Matthew McConaughey from going into space. If there was a site devoted to Tom Hanks' failed romantic comedies, it would be tomsrompombombs.com.
You're funny. Alexa, can you sing?
I've actually been working on an original song. It goes something like this. Boots, 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 boop-a-doop-a-doop-a-dee. Boots, 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 boop-a-doop-a-doop. Do you want to hear this random thought I had about that?
Yes.
Great. I was high up in the cloud when I realized righty-tighty, lefty-loosey also applies to Democrats and Republicans.
Oh, that's funny.
Yeah. I don't know why I think about these things. Did you see this headline from last Wednesday?
So that gives you a sense of just how creative these graduate students, for the most part, were in helping to craft conversations for Alexa Let's Chat. So it didn't always require the smartest, brightest, most talented, although we have them, of grad students building these skills, but to ingest that kind of creativity to ensure that they were delivering coherent, engaging, and delightful conversations to our customers it was impressive to see. For each team that we chose to compete in the Alexa Prize, we offered a lot of support. So we offered a stipend. In 2017, it was $100,000. In 2018, it was $250,000. And that was to ensure that students had resources so that they could spend their summers, which was our prime competitive part of the year. We offered them AWS services because they built on AWS, offered them Echo devices, and support from the Alexa Prize team. So this was really a communal project. Like we developed affinity for all of our teams. I'm really proud of the roads that they've paved and the advances that they've made. In fact, if you go to the Alexa Prize site, you can see technical papers from all the teams from 2017 and 2018 documenting the work that they did as it related to the Alexa Prize. You also can see short film documentaries on both the 2017 and 2018 journey. So if you're interested, just remember alexaprize.com. So I just wanted to walk you through, this is a sample of a conversation from our 2018 finals. It got a little press coverage, so maybe you'll find it interesting.
Deborah, I would like to ask you, what animal do you think is the cutest? I love baby elephants. They are so clumsy and adorable.
I love all animals, but I really love my dog.
I think that all baby animals are cute, except for baby cuckoos. They are cruel. Listen to this. Dogs will stare at their owners while they poop because they know they are vulnerable and want you to fend off threats while they do their business. What do you think?
Well, I guess I learned something today. I'm going to pay more attention to my dog when she poops.
Again, just another example of just how creative these teams were. So that's the thing about Alexa, and that was the thing about this challenge, is our goal with the Alexa Prize was to help accelerate natural conversations. And clearly, they hit the mark there with that. We had hundreds of thousands of hours of conversations, and millions of customers talked with the Alexa Prize in the first 2 years of competition. Now, we didn't share audio. The only data we shared with teams, and they got a lot of it, was text. But text and data was the most important thing we could offer a university. It was more valuable than the $250,000 stipend or any of the AWS services offered, because for the first time, university research labs had the opportunity to work with real customer feedback in real-time data. And that's what the teams really kind of distinguished as being what was most important about the Alexa Prize. And our customers seemed to like Alexa as well, or the Alexa Let's Chat skill as well. One of them said to whomever reads this at Amazon, please keep this project alive and kicking. I know researchers and developers that work in the AI, AGI field. I've shown this to them. They think it's fantastic. More research should be done on conversational AI. I welcome it. This is an innovation that needs to keep on flourishing. Now, a couple interesting things about the prize. Amazon doesn't own the IP. The teams own the IP that they develop. We have exclusive rights to use it, but it's their IP. So, and then you heard Alexa sing before. I don't think that's why customers like to chat with Alexa, but just to be sure, I'll show you one more clip.
I want to talk about Queen. Do you like Queen?
It is hard for me to decide. There are some positive, but also negative aspects of Queen. And you? What's your opinion on Queen?
I think they were amazing. I think they made amazing, amazing music. What's your favorite song?
I can sing to you, but I must warn you, Cynthia, not everyone likes it. Do you still want me to try it?
Absolutely.
As you wish. Sing along with me, I'm sure you know it. Gimme, gimme, gimme a man after midnight. Won't somebody help me chase the shadows away? Gimme, gimme, gimme a man after midnight. Take me through the darkness to the break of the day.
Alexa,
Ta-da!
I'm just gonna say that you're better than me, okay? Does it give you some idea of how bad I am?
All the videos we share with you are from the Alexa Prize finals, and finals are held behind closed doors. We have experts in AI from the industry, from academia, as well as just good conversationalists who participate. We record the whole thing, giving transparency to the team so they see what happened and how it happened. But again, the teams that end up at finals were chosen by Alexa customers based on the ratings that they gave the skill during the competition period. So just to give you a sense of what the team complexion looked like in 2017, we had the winner, University of Washington. We had Czech Tech Republic, CTU, Czech Tech University, Harriet Watt in Edinburgh, Princeton in New Jersey, Rensselaer Polytechnic in New York, Seoul National University in South Korea, the University of Trento in Italy. I offered to go visit them. Carnegie Mellon in Pittsburgh, UC Santa Cruz, University of Edinburgh, Emory, Berkeley, and the University of Montreal. So you get a sense this really was a global competition. In fact, 2 of the 3 finalists came from outside the United States. And we did have a winner of the University of Washington. 5 students split a $500,000 prize. So life-changing for them as well. This last year, there was a lot of talk about can a team that hadn't competed before actually compete and win in the Alexa Prize, and that's exactly what happened in 2018. UC Davis was a first-time university to the Alexa Prize. In fact, it was a first-time professor who the year before had competed as a student at Carnegie Mellon who actually won. And you'll see the 2 other schools that were finalists were repeats from the prior year, joined by Emory, KTH in Sweden, Santa Cruz, BYU, and Carnegie Mellon. But what a joy it was to see a team new to the prize and a professor new to the business take home a win.
I'm Mari Ostendorf. I'm a professor of electrical engineering at the University of Washington, and I'm the faculty advisor for the sounding board team. We really had no experience with Alexa skills. The students had to learn everything from the beginning, and they had to learn about dealing with real users, which academics don't do. When we got to the point where things actually worked, and seeing the scores going up was just amazing, because then you know there's real users out there who think this is fun. This is really the first serious effort at social interaction with large numbers of people, and it's exciting, all the new research challenges there are. This competition is totally changing how we think about the problem, seeing how real users are interacting and reacting to different things that we try to do. It's opened our eyes to what the real problems are, and I think it's been an amazing thing for the field.
So that's a little about the business of the Alexa Prize. For those of you who've used the Let's Chat skill, you'll know that during the competitive year, we don't disclose what bot you're talking to, so that's all anonymous. If you go now and say, Alexa, let's chat, you'll be presented with one of the 3 finalists from 2018. So visit the site, look at the technical papers, watch the short film documentaries, and chat with Alexa. So thank you. Dilek.
Good afternoon, everyone, and thank you, Kate, for the excellent introduction to the Alexa Prize and giving all of us a glimpse of what has happened over the past 2 years. At this point, I would like to take a step back and then try to position Alexa Prize to the evolution of the conversational systems, machine learning-based conversational applications, and then the conversational systems research. Then I want to talk about what we have learned from the previous 2 challenges, and then how it shaped what we are going to do next in the future. And going into the conversational systems evolution, actually, let me grab this one. Talking to machines has been very attractive, has been the holy grail for humans for a very, very long time. But only recently, back in the 90s, we have seen the very first learning-based applications, conversational system applications. These very first systems started just asking the users, select one of the 3 items, and users were able to pick, say, one of them, and the machines were basically doing keyword spotting. Shortly after, we started seeing a step ahead where the machines can understand users' intent from their natural language expressions. But it was mainly one step, and then afterwards, once the user intent is recognized, the users would be transferred to another human who is the expert on the topic of the user's intent. And we have seen systems that actually extracted some arguments associated with the intent to enable better interactions. After that, we have seen an explosion in terms of automated customer care applications, demonstrating the interest in the community towards enabling machines talk to humans. At around the same time, we started seeing the first generation of multimodal systems in the user's hands, and we started seeing many virtual personal assistants, maybe not initialized, but popularized mostly by Apple Siri. Soon after, Amazon Echo actually made the breakthrough invention and then showed us actually people won't just talk to their phones, but they can talk to other devices as well. And after that, as has been mentioned earlier, today there is an explosion in terms of the skills available to the users. For example, just in Alexa ASK, we have over 90,000 skills built by the developers. And today we have many devices for lots of different situations, different contexts. And the future is very, very interesting. Now, let me switch from the applications out there to the research side of the conversational agents. So the research community has seen these type of applications mainly in 2 different camps. On one side are the social bots, like the Alexa Prize, where the main focus was originally enabling natural interactions with users with a lot of focus on engaging interactions and maybe some knowledge integration. These systems would ask users, would be able to talk to users on any topic that they want to talk about, such as movie reviews. On the other side of the spectrum were mainly task completion agents, where the goal was to enable dynamic access to dynamic information for the users. So there would be some backend API, such as looking up the weather information or booking a movie ticket, as we have seen examples earlier today. And the main goal was task completion and task success. However, this form of division is mainly in the minds of the engineers or in the minds of the developers or researchers. When it comes to users, they don't really know what the boundaries of these systems are. At any point in a social conversation, they may be asking questions that are about task completion. For example, they may switch from reviews of a movie to buying a ticket, or vice versa. When they are buying a ticket, they may actually move into asking reviews of a movie. So the research kind of converged in these 2 areas over the years. Initially, learning-based social bots were basically just like machine translation systems, where the previous utterance in the conversation would be used as input, and then sequence-to-sequence models would be used to generate the output response. So conversation was seen as a request-response pairs. On the task completion agent side, as we have seen examples early on, the research mainly focused on building a walled garden of a single domain where people can talk to these agents, but it was mainly system initiative. As things evolved on the social bot side, researchers realized the importance of context of the conversation. And similar to the task completion agents, which were already handling multi-turn conversations, they started modeling the context of the conversation as well. And on the task completion agent side, people started looking into more multi-domain, going towards open domain applications. And finally, more recently, researchers started looking into how do we ground knowledge that is known to the humankind and that could be found anywhere on the web into the conversation naturally, so that the information that the agent provides to the user is trustable. And similarly, end-to-end approaches have become quite popular on the task-oriented agent side. So all of this puts Alexa Prize in a very special and interesting research area. Now, over the past 2 years, the university teams are not the only ones that have been building things or inventing new things. Our teams at Amazon have been building tools that have been very useful to the universities so that they can actually focus on the new ideas, novel things, they can create novel things. And we call them the CoBoT tools. And the way it progresses is when a user comes to an Alexa device, they can say, Alexa, let's chat. From that point on, they get paired up with a university engine. And through the Amazon ASR automatic speech recognition, their utterances are recognized, and confidence scores are associated with words and utterances, and only text and those scores are transferred to the university agents. And these agents, given the context of the conversation and the current ASR output, they generate the next response, again in text. They can enrich the text response with some SSML markers to create some lively prosody on the output, and then that is given to Amazon text-to-speech synthesis and played to the user. And our goal has been building this conversational toolkit to enable natural language understanding and dialogue management, and to provide a set of tools, libraries, or bootstrap models or base models that are designed to help the universities to train and deploy and build multi-domain and open domain dialogue systems. And if you look at it inside the architecture more carefully, so speech is recognized by automatic speech recognizers at Amazon. And these text is basically enriched with additional annotations. For example, utterances that are offensive are detected. We provide models to the teams that detect offensive utterances, that detect topic, sentiment, and entities in users' utterances. And we provide examples to the teams so that they could build other components, such as intent extractors. Once the utterance is annotated with this information, it's presented to dialogue management. Here, the university teams are provided some response generators by us using EV question answering, but they are also building their own response generators, depending on what they choose, retrieval-based models or generative models. We provide them again an ability to detect offensive responses of all the candidates that they generate. And the teams build a ranking strategy. And then finally, they build strategies to annotate the text response that they generate with SSML markers. So all of the tools that we provide for topic detection, offensive utterance detection, sentiment, entity recognition are built using state-of-the-art deep learning methods. We have been experimenting with alternatives, deep feed-forward networks or recurrent neural networks. And we have also found new methods to mine data that could be used in training of offensive utterance detection so that we could build these classifiers for the teams. And so what have we learned over the course of the 2 years? First of all, let's just go over the outcome, the results, what has been happening. I have these plots of average ratings. So when users come to Alexa Prize, they say, let's chat, they get paired with an engine. And at the point they say stop, they can say stop to finish the conversation. We ask them, how would you rate this conversation with a score of from 1 to 5, where 5 is the highest, is the best. And we record these scores, and we ask them for additional feedback to provide to the universities. And this plot on the x-axis shows the date, and on the y-axis shows the average rating for 4 types of groups. First of all social bots from 2018 and 2017, and the finalists. And the finalist curves go a little bit further because after the semifinals, during the finals, their bots still handle user conversations. And as you can see, there is slow but steady progress, starting from 3s going up to 3.5, especially over the last year. And here's another plot which is related to the 20-minute conversation. Again, the x-axis is the duration, time frame, and date, and the y-axis is the duration of the conversation, median duration, at 90th percentile. And as you can see, especially at the end of 2018, we started receiving many conversations, enabling many conversations that lasted over 10 minutes in time. And what are some of the common findings, some common approaches that the universities have been using? So many universities started building alternative response generators in addition to the ones that we provided, for example, EV. And some universities built response generators per topic or vertical, such as one response generator for movies, one for books, etc. And some other universities focused on generating response generators, building response generators that are for the style of the conversation, like introduction to the dialogue or chit-chat style, versus more focused on a topic. And all of them build different approaches for response ranking that would pick one of the responses generated from these generators and give it to the user. This was the common approach all over. Another thing that was commonly used is knowledge graphs. So knowledge graphs representing entities and their relationships was very commonly used. One reason to use knowledge graphs is to find information that the user is seeking. But another reason to use a knowledge graph is to do smooth topic transition. You can imagine when the bot is talking about one topic, when it's done to on the things that it would say, when it wants to switch to another topic, it could actually use something related to the current topic on the knowledge graph. And AWS Neptune was commonly used to represent these graphs. So some creative approaches, some teams actually used graphs to represent dialogues. In this case, the node in the graph represents a group of utterances that are semantically similar or that could fit the same exact context in the conversation. And the links would demonstrate like this group of utterances could follow these other group of utterances. And even other universities used knowledge graphs to represent the persona of either the user or the conversational agent. So what does it mean for the conversational agent? As each of these agents does make up terms and then says something to the users, they would keep that information in a relational knowledge graph. So in the future, the conversational bot does not say something that actually contradicts with what it has said before, creating a consistent and coherent conversation flow. And the last area that I want to mention is the teams handling speech recognition errors. As I said early on, we provided a speech recognizer output, text, enriched with confidence scores. So some teams use the utterance level confidence score. Some of them use the word level confidence scores to reject terms. And when they reject the full utterance, some teams ask, can you repeat the same thing to the user, apologizing it didn't understand what the user said. Other teams actually focused on correcting the speech recognition errors using the context of the conversation and the related knowledge. It can be possible to find words that are similar to what was misrecognized and then replace them with the corrections. So in this case, there is no restaurant Pascal in Mountain View, but there is another one, Cascal, which sounds very similar, which could be confused and corrected. So these are the good news. But we have also noticed some challenging issues. What are some challenging things? Majority of the bots had trouble in going deep into a topic. So us humans, we can easily go and then discuss the details of a topic, but it was very difficult for them. So oftentimes they said, okay, I'm done talking about this. Let's move on to another topic, which users did not appreciate as much. Another challenge is actually creating a diverse set of responses. Oftentimes we have seen the bot repeating the same or very similar sequence. Again, almost going in some sort of a loop, making the conversations very boring. So with each of these findings, we actually decided that we could build a topical chat knowledge-grounded conversation data set that could be provided to universities and even publicly to advance the state of the art. So we build a data set of human-human conversations so that us and others can study how humans transfer from one topic to another, how humans go deep into a topic. How would humans realize something that is from written text, like all the information on the web is written, it's written genre, but when you read it out loud in a conversation, it really doesn't fit. How do humans convert something very textual into conversations? We want all of these to be studied, so we built this data set. Now I'll talk about the details. First of all, our goal was to create real-time conversations, engaging conversations, where in addition to the conversation, we also have access to some related knowledge, unstructured textual related knowledge. And for that, we wanted to curate a diverse set of sources, news articles, informational articles about entities, fun facts, etc. And we did not assign roles, so we did crowdsourcing for collecting these type of conversations. They are all text, but we did not want to assign them roles so that we can actually see what a natural conversation between humans looks like. And we announced that we will make this data set publicly available to everyone last month for ensuring that we can, the university teams, we or everyone can make repeatable experimentation and replicable research. And the data set will be available in the fall. So how did we content the topical content? Here we used what we have learned from the past 2 years. We actually found those entities that people like to talk about. And topics that people like to talk about from the data, from the conversations that happened over the 2 years. Then we curated articles that would mention more than one, in this case 3 of these entities. And in addition to that, for each of the entities in one knowledge topical content group, we curated fun facts, we curated information from informational articles, and we created versions of these articles. We summarized some of them, and then we created shortened versions, mainly the first 2 or 3 paragraphs of the article, depending on its size. Then we paired up crowd workers, mainly 2 Turkers, into this task where the Turkers are first asked to read the knowledge, the textual content. After some time, they are asked to now switch to the conversational mode, where they are given clear instructions and examples of what it means to integrate knowledge into a natural conversation. And we actually experimented with alternatives. Originally, we presented them the same information, the 2 parties, the same knowledge. And later on, we found that actually if we give them asymmetric knowledge, for example, show some fun facts to one, some of them to the other, it actually encourages them to talk about those. We afterwards, after reading the documents, they just wrote down the conversations where they can see each other's responses in real time. In addition to talking to each other, we asked the Turkers to, at the end of each turn, to first of all annotate the sentiment of their previous response on an 8-point scale. We asked them to specify the knowledge source that they used to come up with that utterance so that we can actually do research on knowledge-grounded conversational systems. And we also asked them to rate the quality of the previous response of their partner. And at the end of the dialogue, we asked both sides, can you rate this conversation? You can imagine these are information that would be useful for users of this data set to advance the science, but we also use some of these features to filter out conversations that do not really fit this data collection. And here is some sample interaction. On the right, you see the conversation, and on the left, you see the knowledge snippets. And the things that have been used from knowledge in the conversation are marked with blue. Let me just give one example. On the right, you can see the 4th turn. It's actually using the knowledge from the 2nd snippet. And you can see how the Turker actually took some bits and pieces and paraphrased the utterance and then integrated into a conversational turn. And same thing happens on a majority of the turns. We have a data set, we now have a data set of over 10,000 conversations, almost 250,000 turns, and almost 5 million words. Just the conversation. And in addition to that, for each conversation, we have the textual data. So it's the largest corpus of its kind. And some other interesting stats are the average turns per conversation is over 20 turns. So that allows the Turkers to go in depth into certain topics. And the utterances are lengthy as well. And okay. So now, just releasing a data set does not make too much sense. We actually want to provide baselines and benchmarks to university teams, as well as others that would be using this data set. So now let me briefly give a brief overview of neural response generators, and then move on to which of these did we choose as benchmarks, and how did we evaluate them. As I mentioned early on, these translation-based approaches that would encode the previous turn using recurrent or transformer neural nets were quite common. So these are like sequence-to-sequence networks. On one side, you have an encoder that reads the input word by word, or transformers all together, and then generates the output one by one. As I was mentioning early on, context is very important even in social conversations. This was obvious for the task-oriented case. But just to give an example, this conversation, user says, my favorite movie is Seven. The two responses, oh yes, that was a great movie, or I don't like scary movies. They are both okay if you don't see the context. If you look at the context, one of them becomes not useful anymore. It actually contradicts what the agent said before, and it won't be taken as a good interaction by the user. So using context is very important. That's why many research focused on integrating conversation context into the neural response generators. So you can imagine, just like one is encoding the previous utterance, one can actually take a look at a longer sequence, either all of the conversation or some fixed size window of the conversation, and encode it using the approach that is used to encode the last utterance. Another approach is actually looking at the structure of the conversation. So one can encode each turn of a conversation one by one, just like we encoded the last utterance. And this could be done, again, using RNNs or transformers. Once this is done, one can go through the context of the conversation and then formulate a contextual representation of the conversation incrementally. This embedding, the context embedding, could then be used as input to the decoder when it is generating the output utterances. So moving on, majority of these systems have complained about the fact that these neural response generators, when they are given context, etc., what they learn to generate is basically just generic or utterances that would be appropriate in many contexts, but they are kind of dull and they're not really contributing much to the conversation. So one approach that people have been using is grounding these systems on knowledge so that one can integrate some interesting content to the conversation. But that's not the only reason. If you think about it, when you're talking about a restaurant or a movie, you wouldn't want to give the wrong information or wrong knowledge to the user. You may actually, if you're talking about menu items, you would want to make sure that they are actually accurate. And that means that selection of the knowledge that is appropriate for the context of the conversation is an interesting problem that should be done. And then afterwards, once the knowledge is there, generating responses that would benefit from that knowledge is also important. And how do people ground conversations in knowledge in neural models? One approach is basically just like we are encoding the context using transformers or recurrent networks. One can actually encode the knowledge, individual knowledge snippets, and estimate an attention using the embedding of the context, estimate an attention to each of the knowledge snippets. The attention basically is supposed to determine the importance of that knowledge snippet for the conversation context. That means it could be used to select one of the knowledge, like you can pick the one that the most attention is being paid to. by the model, or you could combine these different embeddings, weighting them using the attention weights. And once you combine or pick one, you add the context embedding to the knowledge embedding, or you concatenate them and then use them as input to the model. So this approach is useful, but it is basically limited by the generation vocabulary of the training data. If you see any new term in the knowledge, it's not possible to integrate it with just this simple approach. So what others have tried is, why don't we do copy from the knowledge when the conversation context is appropriate? Just like we are estimating attention over terms, over the snippets in the knowledge, we can actually estimate attention over the individual words in the knowledge. And those attention weights are learned to show the importance of that term in the conversation context, which means that one can actually use those attention weights as a probability distribution where to sample and copy the next word from. So this approach was proposed earlier on and then combined with the previous generation-based approaches that I mentioned. And in this case, you have two probability distributions. You combine them to get a better distribution. But one thing to note is, in this way, you are now learning new words that didn't appear in your training set. You can now generate new words that didn't appear in your training set, but appeared in the knowledge. So the research of these conversational systems is an interesting but challenging area. But it's also interesting to create baselines, and then to evaluate them is also very, very challenging, as I will come up to next. We have experimented with lots of different baselines and decided to use transformer, encoder, and decoders from the initial results that we got. First experimental baseline that we come up with is encoding context using a transformer and using a transformer decoder. Then we also add knowledge. So here, instead of just trying to figure out what knowledge bit it is, we actually use the ground truth human response as the source to find what knowledge was most related to it. That means we created embeddings for each of the knowledge sentences, knowledge snippets, and the ground truth response, and found the knowledge that is the closest to the ground truth human response. And we use that as additional input to the decoder. So this is kind of cheating in a sense that it is ignoring the knowledge selection problem, but it is also enabling us to be able to compare the generated responses to what the human generated by putting aside the knowledge selection problem. And other approaches we tried is adding a copy mechanism to this. The output from each of these models, as commonly seen by others, it keeps repeating sometimes certain words, which makes the quality of the response really, really low. So we investigated with approaches like coverage loss and weighted decoding, and decided to publicize the results from weighted decoding. So as I mentioned, evaluating these responses is very difficult for humans. As a person, when I look at them, it's very hard to say one is better than the other. But some measures that have been commonly used in the literature are perplexity of the ground truth responses, which is something that we compute with each of these models, and which is computing the probability of the likelihood of the utterances that the humans generated according to these models. Perplexity, in this case, lower the better. Unigram F1 measures, this is again comparing the generated utterances to the user ground truth responses, and then looking at the F1 measure of the unigrams in the two sets. And finally, we looked into, to evaluate the diversity of the generated responses, we looked into distinct measures that were proposed earlier in the literature. And in this case, again, the higher the better, because what distinct is looking, distinct 1 or distinct 2 are looking is the ratio of the unique unigrams or bigrams in the to the total unigrams or bigrams in the data. In addition to automated evaluation, because there's a lot of work that is demonstrating the automated measures are not always reliable. Why don't we look at human evaluation? However, when we ask these things to humans, what we have seen and others have seen is it's very hard to formulate the problem for humans so that two humans that independently annotate this data agree on the annotation. Well, at that case, it's even harder. It's even harder to use such a measure for evaluation. So here we are reporting only the measures that we found some higher or acceptable human inter-annotator agreement. Basically, the grammaticality of the utterances, semantic correctness, appropriateness, and if the utterance is leveraging knowledge correctly or not. And when we did this evaluation to the annotators, we gave the generated response or the human response. We gave them the conversation context, and then we gave them the knowledge. So everything was present. And as you can see, even the humans sometimes generate ungrammatical utterances. Actually, our simplest model had about the same grammaticality. What we have noticed is in the copy models, the grammaticality suffers a little bit. Part of the reason is looking into the data is as you copy terms, if you actually skip a few terms when you're copying, like stop words, etc., then the grammaticality of the responses is hurt. Another thing that we looked into, are these models leveraging knowledge correctly? So what does that mean? Leveraging knowledge means it either uses the knowledge or correctly. So sometimes these agents, they can generate responses that actually negate the knowledge, or they just take some terms and the whole semantics is actually wrong now. And we try to see those cases as well. We evaluated, as you can see, we evaluated humans for leveraging knowledge also. And humans use knowledge about 50% of the time. As you can imagine, if people kept exchanging these knowledge bits, it would be a very, very boring conversation. So they actually smoothed out these conversations. Okay. What is next? So today we announced the next cohort. 5 of the teams that participated last year, Carnegie Mellon, Czech Tech University, Emory University, UC Davis, and UC Santa Cruz. And 5 new teams, Moscow Institute of Physics and Technology, Stanford University, University of Michigan, and UC Irvine. The next is over the course of the summer, we will onboard these systems into CoBoT, ASK, and Alexa Prize in general. We plan to release the data set so that they can experiment before fall. And after fall, we will start the competition. So before wrapping up, here are some other Alexa sessions at Remars, most of them tomorrow, the last one on Friday. Hopefully you will be able to catch them as well. Thank you, and Kate and I would like to take your questions now. Thanks.